Nature keeps a very delicate balance. Beautiful, but fragile. Look, but don't touch. An example of this are the pollinators, a series of organisms that, at their most basic level, take pollen from the males of plants and carry it over to the females of others. However, since the mid-20th century, pollinator populations have been on the decline, likely because of many complex human-caused and natural factors. The North American rufous hummingbird has lost over 60% of its population from 1966 to now. South Florida's Miami blue butterfly has been limited to a single wild colony, and just about 90% of Britain's wasps have met a mysterious end. Likely the most famous example of a dying pollinator is the bumblebee. Certain species of bumblebees have had their populations dip by as much as 90%, causing many events to raise awareness. And such is appropriate. According to PBS, those at particular risk from population decline include residents of countries like Mozambique, where as much as 56% of the population could be at risk of malnutrition if pollinators disappear. A study by the team of Dave Goldson at the University of Sussex found that insect population is vitally important to terrestrial ecosystems and to crop production. The oft-quoted statistics are that 75% of our crop species benefit from insect pollinators, which provide a global service worth $215 billion to food production. Clearly, pollinator population decline is a major issue. In order to understand the steps that we can take against it and to prevent it, we must thoroughly analyze the causes such that we can have a deeper understanding of the issue. Most studies agree that human activity leads to the decline of pollinators. One of these human-caused factors is the overuse of certain pesticides. To give a sense of scope of pesticide and insecticide use in developed nations, the United States makes up 2.6% of the world's agricultural sector GDP-wise, but uses over 20% of the pesticides. One notorious pesticide that they overuse are neonics, or as their full name would be, neonicotinoids. Research from Canada found that neonicotinoid insecticides have been implicated as a key factor in global bee decline and are contributing to hummingbird decline. Neonics utilize nicotine as one of their primary ingredients. Nicotine is most famous for being an ingredient in cigarettes, which they themselves cause 4 of the 5 top causes for human death in the USA. Neonics have been found to be deadly to pollinators, decomposers, and other organisms that truly help the growth of a crop. Neonics were first introduced in the 1990s, which is about when the decline in many pollinators' populations began, and they currently make up 25% of the global pesticide market. The University of Sussex study mentioned before again finds that it seems very likely that bees living in most arable farmland are routinely exposed to sufficient neonicotinoids to suffer both lethal and sublethal effects. A number of other pesticides have been speculated to be deadly to pollinators, but have not quite been confirmed yet. Research is still being conducted on a lot of these. Many sources agree that more study is required before reaching a verdict. Another human-caused factor may be habitat loss. A Royal Society experiment by the team of Riccardo Bramaco found that wild bee species richness increases with habitat patch size. Essentially, a greater habitat increases the amount of bees that can survive in such an area. The amount of deforestation from 2001 to 2018 was estimated to be 361 megahectares of tree cover, equivalent to the area of India, 6 Frances, or 100 gigatons of carbon dioxide emissions. Clearly, the population of bees is probably being affected by the loss of their habitat. Of course, climate change contributes to this too, because when does it not? Climate change may also create a disparity between the phenology of bees and the blooming of flowers that they feed on. It also changes the range of land that certain plants actually do bloom, decreasing the range that current hives may be effective. Farmed bees also have quite a few issues. They are prone to monocultures, where they are given one single food source which blossoms all at once, leaving bees with little to eat. In humans, eating simply one food results in the overconsumption of certain nutrients and underconsumptions of others, leading to illness. It is reasonable to believe that the same would occur in bees. Finally, some apicultural bees actually pollinate some plants that include toxins which they might not do in nature. An example of this are almond trees, which actually contain small amounts of cyanide that can actually lead to the bee's own demise. While humans bring a lot to the table on the concept of murdering every pollinator on the planet, nature would also like to contribute. A phenomenon in nature is known as colony collapse disorder, or CCD, wherein the worker bees of a colony will leave the queen and her nurses, causing the full colony to, well, collapse. It's not completely known what exactly causes CCD. It is speculated that there are many factors. One of these are pathogens and disease, as stated by a study conducted by the team of Dennis van Engelsdorp. Quote, CCD colonies generally had higher virus loads and were co-infected with a greater number of disease agents than control colonies. A specific type of mite, called the Varroa destructor, is particularly notorious in their damage to bees. According to a study conducted by UF, Varroa have infected the apiculture industry negatively in every country that it has been introduced. They have seemingly destroyed hundreds of thousands of colonies, leading to billions of dollars of economic loss. A number of sources also agree that low genetic diversity may be causing population decline. It's not quite known what is causing the current low genetic diversity. Theories include things like selective breeding in apiculture, and in fact just some nice little Alabama time in bee colonies. However, over-inbreeding eventually produces sterile creatures. Genetic diversity has been reaching dangerously low levels in bee populations, and such may be contributing to CCD. As for the future, not much can really be said. It's more of common sense practices in apiculture that really contribute to what we need to do. In opposition to many of the natural factors described in part 3, really not much can be done. Attempting to remove Varroa destructors is essentially futile, and bee doctors are simply not realistic. Using fewer neonics and allowing nature to run its course will help to prevent the death in many species. Preventing deforestation and other forms of habitat destruction will not only help the pollinators, but it will actually act in favor of every single one of the world's jungle dwellers, which make up a major portion of the world's total population. Climate change at this point just needs to end. That will work for the benefit of literally everything. It will save species, end a mass extinction, save us. Finally, we need to refine our apicultural practices. We need to end selective breeding and monoculture so that bees can live proper lives. With these steps, we may be able to end population decline and save our food.